Hi, I want to quickly run through the first part of 2.1, linear and quadratic functions and modeling. A lot of this should be familiar to you because it is, you studied linear and quadratic functions before. So let's first of all define what a polynomial function is. So a polynomial function looks like this: f of x equals a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus, and it just keeps going in that fashion until toward the end it's going to be a sub 2x squared plus a sub 1 x to the first, and then plus a sub 0, which is just a constant. So this looks kind of intimidating, kind of just a little crazy. But I remember the first time I saw it, I was like, what the heck is all this crap? But it's not so bad. X to the nth power is your first term, and then x to the n minus 1 would be 1 degree less, and it just keeps going down until we finally get down to x to the second, x to the first, and then x to the 0. So that's the standard way to write a polynomial in decreasing order of degrees on x. And the coefficients are named so that they match up with the exponent. So a sub n goes with x to the n, and a sub n minus 1 goes with x to the n minus 1. This is just a name for it, a sub n. It means like a sub 5 would be a name for the coefficient of x to the fifth power. So that's not a big deal. So it just goes right on down, and that's a polynomial. So n on a polynomial, n has to be a non-negative integer. So n can't be a fraction, it can't be negative, it's got to be a non-negative integer. It can't be 0 either. So it's got to be a non-negative integer. So we have f of x then. This is a polynomial. It's of degree n. Whatever the highest degree term on, whatever, or the highest degree is on any term, that is the degree of the polynomial. The leading coefficient is always the coefficient on x to the highest power. The 0 function, f of x equals 0, is a polynomial function. It has no degree and no leading coefficient. The degree of a polynomial, as I said, is the highest value of n. Here's just a few little tidbits that trips people up sometimes. Polynomial functions that have no or very low degrees. 0 function is an undefined degree, f of x equals 0. The constant function, f of x equals a, any constant, the degree is 0, because that's a times x to the 0. Linear function, ax plus b, has a degree of 1, and a quadratic function, ax squared plus bx plus c, has a degree of 2. All right, so first thing we need to do is determine whether or not a function is a polynomial function or not. And in the first one, this is not, because we have a negative exponent. The second one, it is. The third one is not, because the square root of x is actually x to the 1/2 power, and that's not an integer. So there it is. And I think we've already talked about those, so let's move on. A linear function is a polynomial of degree 1. AF of x equals ax plus b. So one thing that you're asked to do is something you've done since Algebra 1 is write an equation for a linear function such that f of negative 1 is 2 and f of 3 is negative 2. Back in Algebra 1, they wouldn't have written it that way. They would have just said, find a function that goes through the point negative 1 comma 2 and 3 comma negative 2. So they would have just given you ordered pairs. Now we're writing it in function notation. So it's the same deal. The slope is going to be y2 minus y1 over x2 minus x1. So you take negative 2 minus 2 over 3 minus negative 1. You get negative 4 over 4, which is negative 1. So that's the slope. We pick either one of these 2 points. I just picked negative 1, 2. So it's going to be y minus 2 equals the slope negative 1 times x minus negative 1, which is x plus 1. That's the answer in point slope form. You can leave it like that unless they designate you to do something else. If you did want to put it in slope intercept form, you could. Well, actually, since they ask you to write it in function notation, we would need to solve for y. So we'll distribute the negative and take the 2 over, and you get y equals negative x plus 1. And in function notation, that would be f of x equals negative x plus 1. A linear function always has a constant slope. No matter what 2 points on the line you pick, the slope will be the same. So no matter what line you have, a straight line, no matter whether you pick this point to this point, or this point to this point, or whatever, the slope is always the same. It's a constant rate of change. And you have a theorem, the constant rate of change. A function defined on all real numbers is a linear function if and only if it has a constant non-zero average rate of change between any 2 points on its graph. Slope is the same thing as rate of change. When you're asked for the rate of change of a function, or the average rate of change of a function, it's called the slope. And here's the average rate of change. Because the average rate of change of a linear function is constant, it's simply the rate of change of a linear function. Average rate of change is going to be very important to you in calculus, so you need to make sure you kind of pay attention to that. The average rate of change of a function is just going to be the slope between 2 points. And I'm not going to go through that. You already know what that is. So here's an example of a problem. Again, the same thing that we did before. You find the slope, y2 minus y1 over x2 minus x1 to get the slope. And you can see here, you can choose either point and you end up with the same answer. We start with point, you always go with point slope form. The 0.62 y minus 2 equals the slope we found, negative 1/3 x minus 6. And then if you use y minus 5 equals negative 1/3, again, the same slope. X minus the negative 3 is plus 3. When you simplify it all out, you get the same answer. Quadratic functions, standard form of a quadratic. How do we find x-intercepts? If you need to find the x-intercepts, you simply set the quadratic equal to 0, and you can use the quadratic formula. Or you can factor, you can complete the square, all the ways you learn to solve quadratics. So let's take a look at some things we're really going to zero in on. Standard form for a quadratic. Y equals ax squared plus bx plus c. There's two ways that we can find the vertex of a parabola. We know that x equals the opposite of b over 2a will give us the x-coordinate of the vertex. So what we can do with that is, if we were asked to find the vertex of this polynomial right here, we know the x-coordinate would be the opposite of b over 2a, which would be 8 over 2 times 2, which is 4, and so 8 divided by 4 is 2, so the x-coordinate is 2, and now we simply find y, or f of 2, and that's going to be 2 times 2 squared is 4, minus 8 times 2 is 16, plus 3, so we got 8 minus 16 plus 3. So we know that that equals negative 8 plus 3 is negative 5. So we know the point is 2, negative 5 is the vertex. And that is also, we can get the axis of symmetry of our parabola is x equals 2. So that's also always gotten from x equals the opposite of b over 2a. So the vertex form of a parabola is y equals a, x minus h, quantity squared plus k. And the vertex is hk. And of course the axis of symmetry is x equals h, whatever the x-coordinate of the vertex is. So example, to find the vertex and the axis of symmetry of this problem right here, 2x minus 7 squared minus 3. The vertex, quite simply, is 7, negative 3 that you get from your h and your k, because it's x minus h, so h is a positive 7, and it's plus k, so it's a negative 3, and the axis of symmetry is just going to be x equals 7. Now this might be the hardest part of, or the thing that gives kids most trouble, I guess I should say, is to take a polynomial in standard form and put it in vertex form. Some people like the dividing method the best. I do not. I think you're going to see why I think you'll like the factoring method best. So let's look at the dividing method. We have y equals 3x squared plus 12x plus 11. And the dividing method means you have to get the x squared coefficient to be 1. So we divide everything by 3, and you get y over 3 equals x squared plus 4x plus 11 thirds. So now you have to go x squared plus 4x plus, well, it depends on whether you want to take the 11 thirds to the other side or not. I'm just going to leave it here on this side, plus 11 thirds, because I'm going to have to bring it back anyway. And then half the middle term, half of 4 is 2, squared is 4. And so if I add 4 here, I'm going to subtract 4 on the same side to cancel it out, so I didn't really add anything. And then I have y over 3 equals x plus 2 quantity squared. And now I've got to add 11 thirds and subtract 4, which is really 12 thirds. So 11 thirds minus 12 thirds is going to be negative 1 third. Then we multiply both sides by 3, and this is where kids make a mistake. You got to make sure you multiply the first term, which is x plus 2 squared, by 3. Then you multiply the second term by 3 and you get 1. And so there's my vertex form. Now I know that the vertex is going to be negative 2, negative 1, and that's pretty good. Now here's a factoring method, and I prefer this method. Y equals 3x squared plus 12x plus 11. So what I like to do is I factor the 3 out so that we have a 1x squared, but I only factor it out of the first two terms. I ignore the constant. So that's going to be x squared plus 4x, and then I put plus blank. And I still have my plus 11 here, right? So if you multiplied all that out, you'd still have the same thing that you had to start with. So now half the middle term, which is 2 squared, is 4. So now, look what I just did here. I added 4 inside the parentheses, but that's really 3 times 4. So if I added, that's a positive 3 times 4. That means I really added 12 to what I had to start with. That means I got to subtract 12. So you can either write minus 12 or you could write minus 3 times 4, however you want to do it. The bottom line is you're done. It's now 3 times plus 2 squared. And now you got 11 minus 12, which is negative 1. And as you can see, it takes less steps, no fractions to deal with. Love it. I vote for this one. Now here's another key problem that you have to know how to do. Write an equation for the quadratic function whose graph contains the given vertex and point. So since they gave you the vertex and they gave you a point, I'm going to use vertex form. And all I have to do, I'll do it in 2 steps, but you can really do this in 1. I'm going to write down the vertex first, y equals a, and then it's going to be x minus an h, which is going to be x minus a negative 2 squared, plus k. So it'll be, k is going to be negative 5, so it's going to be minus 5. Now I'm going to plug in the point. I'm going to plug in the x and the y. And y is negative 27, and that's a times x, which is negative 4. Now that's plus 2 squared minus 5. So negative 27 equals a times negative 2 squared is positive 4. And then I add 5 and I get negative 22 equals 4a. A will be negative 22 fourths or negative 11 halves. I'm done. Once I started this thing out, the only thing I really had to find was the a value. So I found a, and I can now rewrite my quadratic in vertex form. A is negative 11 over 2. It's going to be x plus 2 squared minus 5. Probably if I was doing it right here in this step right here, I would have probably said, I would have just said plus 2 right here to start with, but I was just showing you how. So anyway, there is how you can do a problem like that where they give you the vertex and a point on the parabola. Here's a couple of little word problem examples. Among all rectangles whose perimeter is 200 feet, find the dimensions of the one with the maximum area. So we know that 2L plus 2W is 200 because that's how we find the perimeter. It's L plus W plus L plus W, so there's 2 L's, 2 W's. But you know what? If 2L plus 2W is 200, then 1L plus 1W is going to equal 100. In other words, multiply both sides by 1/2. We need to write the area in terms of one variable. So what we'll do is I'm going to say that L is equal to 100 minus W, which means my area now, instead of L times W, is going to be, the area in terms of W is going to be W times L, which is 100 minus W. So that means A of W equals 100 W minus W squared. And we can go on our calculator and we can figure out where that maximum value occurs. And It says here that the maximum value occurs at 50, 2500. Well, how could we have figured that out? Well, the easiest way to figure it out, you don't even need a calculator. We know that the maximum, this is a parabola that opens down, so it's going to look like that. We also know that it's going to have a 0 at 0, and we know the other 0 is going to be at 100, and we know that the vertex is always halfway between those points at the same height, so we know the vertex is going to be at 50, and so all you have to do then is plug a 50 into the area function. A of 50 is going to be 50, basically 50 for W, and then 100 minus W is also 50, so it's 55 times 50, which is 2500, and that's my maximum area. Another way to get where the vertex is again, the x value of the vertex is going to be equal to the opposite of B. If you look at this form right here, which is negative 100 over 2A, which is 2 times negative 1, and that's, of course, going to give you 50 there as well. So pretty easy to find the maximums for simple little quadratics like that. And I really believe that the opposite of B over 2A is the way to go. But also, you can look at it graphically as well. But opposite of B over 2A is a good algebraic way. And I think I'm going to stop the first